A current carrying wire runs horizontally across a table. The conventional current direction I is running from left to right, and the current carrying wire produces a magnetic field of 3 times 10 to the power of -6 Tesla, measured 15 centimeters from the wire. What current must the wire be carrying to produce that field? And there are a diagram showing the direction of the magnetic field around the wire. So first of all, let's have the wire. It is horizontal, like that, and it moves from left to right. So I is going to be in this direction. In order to find out the direction of the magnetic field, we need to use the right hand rule, thumb toward I, and when you do that, it's going to be like that. So it means that on top of it, magnetic field is going to come out of the page, and this side is going to go into the page. So that's the direction of magnetic field. And if you want to find out the current, we need to use the Amperes Law, which B equals to mu naught times I divided by 2 pi R. I is the current, R is the radius, and B is the magnetic field strength. And mu naught is constant, and it is equals to 4 pi times 10 to the power of -7. So I will be equal to 2 pi R times B divided by mu naught. So 2 pi, R is 15 centimeter. We need to convert it to meter. So 15 divided by 100 is going to be 0.15. And B is 3 times 10 to the power of -6 Tesla divided by mu naught, which is 4 pi times 10 to the power of -7. So pi and pi cancel out, and then these two cancel out. Here is going to be 10, so that will be 2 times 3 times 0.15 times 10 divided by 4. It's going to give me 2.25 ampere. So that's going to be the electric current in the wire.